let's talk about reactions that involve alkenes. So, your alkenes, and remember we identify our alkenes using our carbon-carbon double bond, they undergo addition reaction, right? And they're classified as undergoing addition reaction because two groups are added to the carbons of the carbon-carbon double bond, or we could say two groups are added across the carbons of the carbon-carbon double bond. When the groups are added to the carbon of the carbon-carbon double bond, the double bond breaks and become a single bond. Extremely important, right? So alkenes, they will undergo addition reaction. It's considered addition because two groups will add to the carbons of the carbon-carbon double bond, right? Your double bond will break, leaving you with a carbon-carbon single bond, which this is what we need. So let's say I'm reacting this alkene with X and Y, right? Your carbon-carbon double bond will break, right? Leaving you with a carbon-carbon single bond. Y will add to one carbon, and Y is blue. Y will add to one carbon, and then X will add to the next carbon, of course. In chemistry, things don't just get up and disappear, right? You need to put your CH3s back. So CH3, 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 CH3. So I'm going to call these carbon 1 and 2. That's where your double bond is, right? Notice what we did was we added X and Y. That's why it's addition reaction. Notice that the double bond broke, leaving with a carbon-carbon single bond. That's it. The double bond has to break for these to add or you'll have too much bonds. I'll show you that in a second. I did not lose these. You must put them back. Okay, you gotta put your CH3s back. Now, um, your alkenes undergo addition reaction, but the addition reaction is specifically called, it's an electrophilic addition that they undergo. Electrophilic addition. This is because, right, in the first step, at least the first step, so first step or more, an electrophile is added to one of the carbons of the carbon-carbon double bond. When you watch the videos on individual reaction, for example, hydration, well, that's when you add the water to the alkene, you'll see what I'm talking about. But your alkene reactions are called electrophilic addition because an electrophile is what's added to the carbon-carbon double bond in at least the first step. So let's look at just an example or just a skeleton, right? And let's talk about what we mean. So this is going to be your electrophile, right? And I don't have to put an actual electrophile here because there's so many reactions that you will have to learn, and there will be so many electrophiles for you to see. But I need you to get the idea here, right? So we have the carbon-carbon double bond. Is my bond looking all crooked? You have the carbon-carbon double bond, right? I need you to remember this. Your carbon-carbon double bond is rich in electrons. So this is your source. That pi bond is rich in electrons, so it's your source or your nucleophile. This is in that once you have that double bond, it is rich in electrons and it is willing and ready to give up some electrons to the nucleophile, to the electrophile. That's why in that first step, right, your electrophile gets added to one of these carbons. This is what the mechanism actually looks like. Your electrons from your double bond will make a bond with the electrophile, right? Now, let's talk about what happens when this happens. So you're drawing an arrow from the double bond to the electrophile. When the arrowhead ends here, what we're forming is a bond, not a lone pair, okay? The double bond breaks, leaving you only with a single bond, right? So in essence, when you draw this arrow, what it means is that one, you can write these things down so you remember, the double bond breaks, leaving you with a single bond. Okay? It also means that the electrophile makes uses this line to make a bond with one of these carbons, right? And it depends on the reaction. As you study more, you will see their rules for where it will add, right? So let's do some things. I'm going to call this one, I'm going to call this one, two. Let's put back these bonds, my skeleton bonds here, right? The carbon two also have some skeleton bonds. Pay attention. This is very important for these reactions. My electrophile will add to either carbon one or carbon two. Of course, it depends on the reaction. You'll learn that in a second. We're going to add the electrophile to carbon one. If I add the electrophile to carbon one, what happens to carbon two over here, since the double bond break, is that carbon two now has three bonds. With carbon two only having three bonds, it has a charge. It has a positive charge, and this is what we call a carbocation. There's a video on carbocations, their stability, etc. Extremely important when you talk about reactions with alkenes. Now, your alkene reactions, they also have name. So each reaction will have a name. The name is based on the two groups that gets added to across the carbon-carbon double bond. So for example, if you're adding a hydrogen and an OH, you're adding H2O, that's water. So that reaction would be the hydration of an alkene. If you add a hydrogen and X, where X is a halogen, the name of this reaction, since you're adding, let's say HCl for example, or let me keep HX and give you something general. Where X represents any halogen, this reaction is called hydrohalogenation because you're adding a hydrogen and you're adding a halogen. Here's the thing. For each reaction, in every video that I complete, I'll give you the name. We'll walk through it, the simple way how to quickly get the product, and also we'll do the mechanism. But to name your reactions, just remember the name of the reaction comes from the two groups that you're adding. It's an addition reaction. Once you add anything, you have to break that double bond, right? Because that's the only way you can add it anyway. If you don't break the double bond, the carbon is going to have five bonds. So you have to break the double bond.